Hi, welcome to IT Training Experts. This video tutorial covers DHCP, or the Dynamic Host Configuration Protocol. So any IT professional that has been in the industry for pretty much any period of time has probably worked with DHCP or at least heard of it. So what is DHCP? So DHCP is a standards-based network management protocol that is designed to provide an endpoint with network configuration information. It was defined back in 1993 by RFC 1531. So DHCP has been around for a very, very long time, so it's a very mature protocol. The reasoning we have DHCP was to allow an endpoint to connect to the network dynamically, but the big key there is dynamically. Without DHCP, an endpoint would have to be manually configured, or it would have to auto-assign itself a non-routable IP address. So really it comes down to addressing a couple of issues. Without DHCP, you're having to manually and statically configure endpoints as they're added to the network. So it's just not scalable from a human perspective. Maybe in a small network, but as the network grows over time, it becomes more and more of a challenge to be able to manage an environment that way. Number two, it's error prone. You start having humans have to manually configure devices one by one, you're going to obviously introduce errors in the environment. So DHCP was essentially created to address those two issues. And really we'll throw one more in there, a third one, was to also improve and allow the ease of connecting to the network. Because let's face it, a lot of our users are not very technical. So for them to have to configure an IP address, a subnet mask, a default gateway, all these network information that we would need to have in order for that endpoint to connect to the network would be a challenge for our end users. So DHCP allows an end user to bring a device on the network and they can easily and seamlessly connect to the network. So with that said, most devices today, as well as operating systems, support DHCP. So it's something that is, anywhere from laptops to desktops to smartphones to tablets, and even pretty much any device that can talk IP supports DHCP today. So let's dive a little bit deeper. So DHCP is a client-server protocol. So what does that mean? So a client would be an endpoint. Again, that would be it could be a desktop, a laptop, a smartphone, tablet, any type of device that's trying to get onto the network that needs network configuration information. The server would be the DHCP server itself. So this would be the server that's going to run DHCP, that's going to manage the IP addresses, and essentially has a database that it uses to track which endpoints have which IP address. And that server allows administrators to configure the DHCP server to match their needs or their organization's needs. So DHCP runs on UDP. So on the server side, it runs on port 67, and on the client side, it runs on port 68. DHCP is predominantly a broadcast technology. It does have some unicast capabilities as well. We'll dive into the deeper in terms of when it uses a broadcast versus a unicast communication. DHCP, prior to DHCP, we had a couple other protocols that were used really a long time ago, and that was reverse ARP and BOOTP. And those were used prior to DHCP. DHCP is actually based off of BOOTP. Another thing with DHCP is there's no built-in security. So let's jump into the DHCP operations, or what some in the industry call DORA. So we'll build out kind of a little diagram here where we have a client and a server. We talked about this client-server protocol. And let's say this client is a new laptop and it just arrived at your office. And you power it up. It could be Windows or Linux or Mac OS, any operating system. And the first thing it does, if it doesn't have a static network configuration, is it's going to do what we call a DHCP discover. And what the DHCP discover is essentially a broadcast on that subnet. It's essentially the client saying, hey, is a DHCP server out there? I need an IP address. After that broadcast, that DHCP discover is received by the DHCP server, the DHCP server looks in its database, comes back with an offer. An offer can have several things, but at a very base minimum, it's going to have an IP address, a subnet mask, probably a gateway as well. And it's going to say, hey, would you like to use this IP address with this corresponding network configuration information? And the client would say yes. So what the client does is do a DHCP request back to the server and says, yes, I would like to use that information. And we're still dealing with broadcasts at this point. The client has a TCP IP stack running on it, but doesn't have any IP address. So at this point, it's it's sending broadcasts and it's receiving broadcasts, but it's still using broadcasts because it hasn't configured anything yet. So once the server receives that DHCP request, it goes ahead and on the back end configures that IP information inside its database and then sends a DHCP acknowledgement or a DHCP ACK back to the client. And so when the client receives that, at that point, it's going to go ahead and configure its network information, the IP address, subnet mask, gateway with the information that the DHCP server provided. And that in a nutshell is basically how DHCP works. After it receives that DHCP acknowledgement, there's no more broadcasts from a DHCP server perspective as long as we have the IP address, unless there's some other event that causes the client to generate a broadcast, or further down as we talk about later about what happens as we get closer to the lease expiring. So let's look at the DHCP allocation methods. So the first one is dynamic, and this is one that you see most often in most environments. Is you have a range of IP addresses or a pool reserved for a fixed period of time defined by administrator. This fixed period of time is called a lease, and we'll talk about that a little bit later. This can be just a pool of addresses, and as a client needs an address, the DHCP server will hand out addresses as needed. Not much more other than that. We go into automatic. So automatic is very similar to dynamic, but here the DHCP server actually keeps a record of the previous client's IP address assignment. And it keeps this information for future assignments. So in this environment, if you're using automatic, it starts building a table of what previous clients have used as IP addresses. And those, from a DHCP server standpoint, are preferred addresses. So if it can, it'll continue to use the same address if at all possible. Manual or static is reversed for IP addresses that are mapped to MAC addresses. This one, I've never seen, but I could see in situations where you need that fine level of control, you might want to do that. If you're permitting somebody to have access, if it's for some reason, you may want to have that kind of almost whitelist approach where you're actually defining the MAC addresses that are allowed to get on the network. So let's jump into some DHCP terminology. So the first thing is DHCP scope. So what's a scope? A scope is a valid range of IP addresses, sometimes referred to as a pool, that are available for assignment. So this could be a range of addresses, and this is what the DHCP server uses to give out to clients. Typically, your DHCP scope is defined by subnet. So if you have 10 subnets or 10 offices or 10 networks, you're going to have most likely 10 scopes. Next is lease duration. So this is the amount of time a server holds a client's IP address. And this can range to hours, to days, and even sometimes longer. And there are pros and cons to having a short lease time versus a long lease time. And a lot of it depends on the environment. But really, it gives the administrator the opportunity to control how long they want to have clients hold on to IP addresses. And so as part of that lease, we do have timers. And so the first one is a DHCP, or is a T1 timer, and it's set 50% of the remaining lease. And so about halfway through the lease, the client changes from bound to renewing. And so at this point, it'll send a DHCP request to its DHCP server that originally handed out its address and say, hey, about halfway through my lease, can I continue to use this IP address can you give me in it, and can you reset my lease time so I can continue to operate on the network? And in most cases, DHCP server says sure, and there's no problems. But sometimes, the DHCP server is offline, or there's a network outage, or something happens, and the client doesn't receive any confirmation back from the DHCP server, so the T1 timer expires. So at that point, the client's in a renewing state, and something called a T2 timer is generated. And so what happens there, about 87.5 or 88% of the remaining lease, the client goes from this renewing to a broadcasting a DHCP request. So it's in this renewing state, it's continuing to send unicast messages to DHCP server, but once the T2 timer hits, the lease is almost done. So the client sends a broadcast, a DHCP request out to the network, and basically says, anybody out there, I need to renew an IP address. And the last one is exclusion range. So what are exclusion ranges? Exclusion ranges are IP addresses typically a range that aren't available for assignment. So this is especially common in data centers where you have servers where you want to maintain static IPs. The DHCP server doesn't know if another device has an address or using it in its pool if it's statically defined. Now, if it assigns it, yeah, it does know about it. But if it's statically defined, it does not. So it's just a way there to kind of keep things kind of tidy from that standpoint. Another area you might want to use it as well is for gateways. Gateway would be another one. You don't want to have a DHCP address for a gateway. You want your gateway to have the same address. You'd want to make sure that's part of an exclusion range as well. So let's jump into some more terminology. So what's a DHCP relay or helper address? So we talked about the workflow of how DHCP communicates on the network. Well, DHCP uses broadcasts. So routers by default block broadcasts, and that includes DHCP. So the challenge with that is if you don't have a DHCP server in each network, you would have situations where you would have to statically define each client. And that's where the DHCP relay helper address comes in. You can actually configure a router on your network to take that DHCP request, which is a broadcast when it comes in, and it will actually send a unicast message to a DHCP server, which most likely resides in the data center. So instead of having DHCP servers in every network at every site, it allows you to have a consolidated 1 or 2 DHCP servers in your data center. DHCP options. What are DHCP options? DHCP options are a list of parameters that are assigned to a client as part of a request. So DHCP options is not really a good word. A lot of times they're required, but options allow you to add additional information other than just an IP address. So here's some examples of some that are very common, that are really more requirements than options. Hope you enjoyed this video tutorial, and thanks for watching.